Okay. So, alright. Which one's u and which one's dv?
Yep.
Which one do you want to do the derivative of? E to the x, since it's plain e to the x, it's going to be e to the x whether we do a derivative or we integrate it. So that one's not going to be an issue. So it's a matter of do you want to do derivatives of cosine or do you want to integrate cosine?
Let's do derivative. Integrate e to the x.
Okay. So I'm hearing derivative of cosine. So you want u to equal cosine.
Yeah.
And you want dv to be e to the x. So the derivative of cosine will be negative sine. And the integration then of dv will become v equals e to the x. You really gotta love e. It's awfully friendly. So now, u times v I'm doing u times v minus the integration of,
Negative sine of x.
okay, it's going to be v, so can't I take the negative and make it be a plus then? So it's going to be plus e to the x times sine of x, isn't it?
That's not the same thing.
Nope, it's not the same thing. So,
But we're going to have to do it again.
We're going to do it again.
aren't we stuck in the same place? We've got two different functions. We can't integrate those. So we're going to do it again. And once again, set it up in the same pattern. Don't reverse it. Since u was a trig function before, u needs to be the trig function again. So, okay, we'll do it again. U sine makes dv e to the x again, e to the x dx. Derivative is positive cosine, yes. And v is just going to be e to the x. So I'm going to have first, then when I do another uv, I'll have a positive e to the x sine x minus the integration of the bottom two, e to the x cosine of x.
It's impossible.
Have we seen that anywhere before?
Very beginning.
Isn't that?
Oh, it could be like cosine plus sine equals...
Isn't this this e to the x cosine of x the exact same thing we started with? That's dx, not du, though. That's identical to what we started with.
It's impossible.
Okay.
Because that's going to be e to the x cosine x, and then that's going to be e to the x sine x. So is it 0?
Not 0.
1.
I'm going to rewrite here a second. I need to bring down the original problem a second. This is the original thing we started with. And we now have this other lovely stuff. If those two are the same integrations, what algebra can I do here?
Subtract them.
Well, close. Aren't these two integrations the same thing? So if I add it over, wouldn't I have two of them? Yeah, so I can add it over and say I have 2 times e to the cosine x, e to the x times cosine x dx.
So then you just divide by 2.
Bingo.
Wow. Plus c.
And so then, remember, your goal is to solve for this integration. So you can just divide it by 2 and you have solved for that integration.
And where does the c go?
Out of the and past it. So you would just say, oh, I have all of this divided by 2 with a plus c on it.
Okay.
It's really
When
sneaky.
you end up with the same, just subtract the function over.
Well, technically, actually, you're adding the function over.
Add the integration over.
Add the integration over to the original. And divide by that number. Now, to do something like that, it has to be 2 functions that just keep switching back and forth as you do the derivatives or integrals. They just keep switching back and forth between the same values.
And divide by.
I mean, there aren't lots of functions that would do this, but it's pretty cool. You got it? So there you go. Integration by parts. You can now reverse the product rule. Woo! I expect you to go home tonight and tell your parents that you can reverse the product rule.
My parents will be like, what's a product rule?
and sing to them, B minus B integrate, you have to make up a rhythm for it, you have to sing to them. Oops, I didn't went that far. Recite. If you start muttering weird things like UV minus integration of VDU, they'll think you've lost it.
Oh no, there it is.